Hey, so today we're going to go ahead and look at operations with polynomials. So with operations, I mean adding, subtracting, and basically multiplying. We're going to kind of skip dividing because we'll do that in about 2 chapters. Okay, so whenever we're working with polynomials, we kind of want to know what like terms are and to see if we can find the like terms. So like terms, y'all kind of already know this. We did this in a previous chapter. We only added x's and x's and y's and y's. So like terms are the same variables raised to the same exponent. So x squared and x squared would be like terms, but x squared and x would not be like terms. We can combine like terms, meaning adding or subtracting like terms by, well, adding and subtracting the coefficients. Coefficients, a number in front of the variables. So if I look at the example here, 3x squared y cubed minus 2x y to the 6 minus 8x cubed y squared plus 7x squared y cubed plus 5x cubed y squared. It's 5 terms. Terms, as we said previously, are anything separated by a plus or minus, or products separated by a plus or minus. So I have 5 terms right here, and I want to find the like ones because I can combine those. So I have an x squared y cubed. So I have 3 of them here. If I go through the rest of my terms, I see I have another set of x squared y cubed right next to my 7. So I have 3 of them at the beginning, 7 of them over there, so I can go ahead and add them and get 10. X squared y cubed. That's why it's called combining. We're trying to just basically simplify it. Instead of having it be 2 terms, simplify it so it's only 1 term. Easier to write. Okay, so I'm going to go my next one, minus 2x y to the 6. There's no other term in there that is the exact same or a like term, so I can't simplify it. It's already down to 1 term, so I'm just going to recopy it, 2x y to the 6. Okay, I'm going to go to my next one. I have 8x cubed y squared. If I look down to the last one, I have 5x cubed y squared. So those are like terms because they have the same variables raised to the same exponents. Should put an S there. So minus 8 of them here. If I add 5 of them here, then I have minus 3 x cubed y squared. So you don't change your exponents when you're doing this. You're just counting how many of those terms you actually have. Okay, so if we're going to talk about terms, we should real quick define what different expressions are. So monomial we already talked about. That's something that's just 1 term. So such as 3x squared. That is a monomial. There's no plus or minus. Binomial is 2 terms. So something like 3x squared plus 2y would be a binomial. Trinomial would have 3 terms. So 3x squared plus 2y minus 7, let's say. Polynomial is many terms. So usually anything that's more than 3 terms we just call polynomial, which is why I called the previous one a polynomial. Okay, so something like 3x squared plus 2y minus 7 plus 23x squared y. So even though I used x squared y again, I can't combine these because they're not the exact same variables raised to the exact same exponents in 1 term. Other word we should know is probably constant. Constant is the term that does not have a variable, therefore it doesn't vary. It's called a constant. So in this case, my constant would be minus 7. And coefficient. Coefficient, as I said earlier, is the number in front of the variable. So in case of my x squared, the coefficient would be 3. Okay, so let's combine some of these, or add and subtract them to see some actual operations. So I have 3 binomials here. I got a 3x of 4th y is 7 plus 8x of 5th y. I have going to add on to that a binomial, 4x of 6y cubed minus 2x of 5th y. And I'm going to subtract from that a binomial, x of 6y cubed plus 7x of 4th y. So they're all in parentheses. We know from previous that we always want to get things out of parentheses first. Parentheses usually indicates multiplication, so I'm going to multiply by something. Well, in my first parentheses, I don't have anything in front of it. We know that if we don't see a coefficient, we can always write in 1, so I'm going to write in 1. Multiplying through by a positive 1 doesn't change anything. So this can actually just come out. 3x of 4, y to the 7, plus 8x of 5th y. Same with my second one. My second one has nothing in front of it, so I can write in a 1. Again, multiplying by positive 1 doesn't change anything, so it can just come out of the parentheses. So 4x to 6 y cubed minus 2x to 5th y. Last one's a little different. Again, there's nothing in front of it, so I can write 1 in, but that's a minus 1. I have to distribute that minus 1. I'm subtracting both parts of this parentheses. So I'm going to distribute that minus 1, so I have a minus 1x to 6 y cubed and a minus 7 x to 4 y to 7. Now I'm going to look for like terms. I got a polynomial right now, so I got x to the 4th y is 7. I have 3 of them at the very beginning, and I have minus 7 of them at the very end. So that's going to give me minus 4 of those x to the 4th y to 7. My next term is x to the 5th y. I have 8 of them, and further on I have minus 2 of them. So that would give me a plus 6 x to the 5th y. My next one would be x to the 6 y cubed. I have positive 4 of them. Later on I have minus 1 of them. So that would give me a plus 3 x to the 6 y cubed. Check, make sure I can't simplify anything else. I can't. I have no more like terms, so I'm done. Okay, so I'm going to move on to the next one. My next one, got a trinomial minus a trinomial, so 5x to 6y minus 3 plus 2x cubed y to 9. Again, nothing in front of that, so I'm going to put in a positive 1. Multiplying through by a positive 1 doesn't change anything, so the whole thing just comes out. So 5x to 6y minus 3 plus 2x cubed y to 9. Second parentheses, I have a minus 1. So I am going to have to distribute to make sure I'm subtracting everything in that parentheses. So minus x to the 5th y cubed minus 12x to 6y minus a minus is plus, so plus 3x cubed y to 9. I'm going to look for like terms. My first set is x to the 6y. I got 5 of them at the beginning. I'm subtracting 12 of them later on. So minus 7 x to the 6y. My next term is a minus 3. But the constant, I have no other constants. So I'm just going to recopy it as a minus 3. My next set is x cubed y to 9. I have positive 2 of them at the beginning and positive 3 of them at the end, so I have positive 5 x cubed y 9. And my last one is d minus 6x to the 5th y. There's no other term like it, so I'm just going to copy it. Minus 6x to the 5th y. Check to make sure I can't combine any other terms. I can't. I have no more like terms, so I'm done. Okay, so my last one, I got monomial times a binomial plus a monomial times a binomial minus a monomial times a binomial. So I got a lot of stuff happening. So this time, I do have to multiply by things to get them out of parentheses. I have a 2x squared y cubed in front of that 4x squared plus 6y cubed. So I'm going to take that 2x squared y cubed and multiply it times both parts inside the parentheses. I'm going to write it out for the first time. So 2x squared y cubed, and I want to multiply that. I'm going to use a dot for multiplication, times 4x squared. Then I have the 2x squared y cubed. I want to multiply that times the 6y cubed. That's a plus times a plus, so it's going to remain a plus. And then onto that, I have 5x squared y being multiplied by my other binomial. So I'm going to write that out. 5x squared y times 3x squared y to the 4, 5x squared y times 2. It's a positive times a negative, so that's going to give me a negative. We'll do these two and see if we can do the last one without actually writing it out. Okay, so if I multiply these together, it's the same as we did with exponent rules. I'm multiplying common bases, so I'm going to add the exponents. Start off with my numbers. 2 times 4 should give me 8. X squared times x squared will be x to the 4. Y cubed is just y cubed. Okay, my next term, 2 times 6 would give me 12. X squared, nothing else to multiply it with, so stays x squared. Y cubed times y cubed, y to the 6. So next one, 5x squared y times 3x squared y to the 4. 5 times 3 is 15. X squared times x squared is x to the 4. Y times y to the 4 is y to the 5. Next one. So minus 5x squared y times 2. Minus 5 times 2 is minus 10. X squared is just x squared, and y is just y. Okay, so see if we can do the last one without actually writing it out. It's minus 6x, so we're going to bring it down here so we can skip this step. Minus 6xy to the 4 times x cubed y plus 7xy squared. So minus 6xy to the 4 times x cubed y would be minus 6, since that would be 6 times 1. X times x would be x to the 4. Y to the 4 times y would be y to the 5. Now I need to distribute to my second one, so minus 6xy to the 4 times 7xy squared. Minus 6 times 7 would be minus 42. X times x would be x squared. And y to the 4 times y squared would be y to the 6. Okay, now I have a polynomial. I just need to find some like terms. So my first term, 8x to the 4y cubed. No other term like it, so I'm just going to bring it down. It's already simplified, so 8x to the 4, y cubed. Second term, 12x squared y to the 6. I do have another one that's like it. I have that minus 42x squared y to the 6. So that'd give me minus 30 x squared y to the 6. My next set would be x to the 4 y to the 5th. I have another one that's like it, minus 6 x to the 4 y to the 5th, so 15 minus 6 would be a positive 9 x to the 4 y to the 6. And I still have the minus 10 x squared y, and I was already simplified, so I'm just going to recopy it. Okay, check, make sure I can't simplify anything else. I can't, so I am done.